Section 3.1 Complex Numbers. Learning objectives. In this section, you will learn express square roots of negative numbers in terms of I, add and subtract complex numbers, and multiply and divide complex numbers. Let's recall. Square root of negative 1 is equal to I. And then if we square both sides, square root of negative 1 squared is equal to negative 1. So that's why I squared is equal to negative 1. The imaginary number I is called the imaginary unit. Any square root that has a negative number inside it is called an imaginary number. Okay? Example number 1. Express the square root of negative 25 in terms of I. So square root of negative 25 in terms of I, we know that the square root of negative 25 can be written as negative 1 times 25, or you can rewrite this as square root of negative 1 times square root of 25, and square root of negative 1 is an I, and square root of 25 is 5. So the answer is 5I. So remember, I is equal to square root of negative 1. A complex number is any number in the form of a plus bi, where a and b are real numbers. For example, 5 plus 2i, the 5 part is the real part, the real number, and 2i with an I is an imaginary part. So we like to write complex numbers in standard form, a plus bi, and let's have some practice. Example number 2, express square root of negative 9 in standard form. Square root of negative 9, again, we know that negative 9 is negative 1 times 9, and square root of negative 1 is I, square root of 9 is 3. So this is equal to 3i. And writing it in standard form, you can rewrite this as 0 plus 3i, whereas 0 is the real part and 3i is the imaginary part. Okay. Adding and subtracting complex numbers. Complex numbers are numbers after all, so we can add and subtract them in the following way. Example number 3, compute 3 minus 4i plus 2 plus 5i, and compute 2 plus 5i minus 3 minus 4i. So let's do that. So this one is just like combining like terms. So 3 plus 2 is 5. Negative 4i plus 5i is equal to I. So this is in standard form. This is the real number 5 and I is the imaginary part. The other one, compute 2 plus 5i minus 3 minus 4i. So this is 2 plus 5i. You distribute the negative. That is minus 3. Negative times negative 4i is positive 4i. And then simplify. Combine like terms. 2 minus 3 is negative 1. 5i plus 4i is 9i. Okay. Next, multiplying complex numbers. We can multiply complex numbers by real numbers and other complex numbers as well. find the product of 4 times 2 plus 5i. So what do we do here? So we distribute 4. 4 times 2 is 8. 4 times 5i is 20i. So again, 8 is the real part, and this is the imaginary part. Okay, let's try the next one. Multiply 4 plus 3i times 2 minus 5i. So I'm going to rewrite it here. So I have a space here. 4 plus 3i times 2 minus 5i. So 4 times 2 is 8. 4 times negative 5i is negative 20i. 3i times 2 is 6i. And 3i times negative 5i is negative 15. I times I, don't forget this, is I squared. And what do we know about I squared? I squared is equal to negative 1. So we do that. So 8 negative 20i plus 6i is negative 14i minus 15. I squared is equivalent to negative 1. Negative negative is positive, so plus 15. So now this is 8 combined like terms. 8 plus 15 is 23 minus 14i. So this is the answer in a standard form, real and the imaginary part. Next one, dividing complex numbers. We can also divide complex numbers, but since they have radicals, we have to rationalize the denominator to simplify our results. We do this by multiplying the top and the bottom by the complex conjugate of the denominator term. So what do we mean by complex conjugate? So the complex conjugate of a complex number a plus bi is a minus bi. It is found by changing the sign of the imaginary part of the complex number. The real part of the number is left unchanged. So for example, find the complex conjugate of each number. Letter A, 2 plus I square root of 5. And the conjugate is it says by changing the sign of the imaginary part. So this is plus I squared of 5. So it's going to be 2 minus I squared of 5. Okay. Letter B, 7 minus 1 half I. Changing the sign of the imaginary part. Then the conjugate is, yes, 7 plus 1 half I. That is correct. Easy, right? Next, divide 2 plus 5i by 4 minus I, and remember to express the answer in standard form. So with this, I'm going to rewrite it here, 2 plus 5i over 4 minus I. So what do we do here? To rational, when we divide this, we multiply the top and the bottom by the conjugate of the bottom. So multiply the top and the bottom by the conjugate of the bottom. So what's the conjugate of 4 minus I? Yes, it's changed by changing the sign of that. So 4 plus I. So multiplied by 4 plus I over 4 plus I. Then you can simplify this now. So 2 times 4 is 8. 2 times I is 2I. 5I times 4 is 20I. 5I times I is 5I squared. All over 4 times 4 is 16. And I, negative I times positive I is negative I squared. So just to recall, I squared again is equal to negative 1. And also what I did in the bottom, 4 minus I times 4 plus I, is just like the sum and difference of two binomials, meaning it's just x times x is x squared, y times y is y squared. So that's what I did here. We just multiply 4 times 4 is 16. Negative I times positive I is negative I squared. Next, 5I squared. I squared, we substitute negative 1 to that. 2I plus 20I is 22I plus 5 times negative 1 all over 16 minus I squared again is negative 1, so minus 1. So what is this equal to? 5 times negative 1 is negative 5. 8 plus 5 times negative 1. So 8 minus 5 is 3 plus 22I. 16 minus negative 1 is 17. So write it in standard form. So that's going to be 3 over 17 plus 22 over 17I. Okay, so 3, this is in the form of standard form A plus BI. 3 over 17 is the real part, and imaginary part is 22 over 17I. Alright, next, simplifying powers of I. Finally, let's see what happens when we take higher powers of I. So let's start with what we know. I is, we just, in simplified, we just write it I. I squared is, what do we know about I squared? That's correct, negative 1. I cubed is, we know that this is I squared times I. So I squared is negative 1 times I. So that's why this is equal to negative I. So I cubed is equal to negative I. Next is I to the 4th is I squared times I squared. We know that I squared is negative 1, so negative 1 times negative 1 is equal to positive 1. Alright, so what do we have here? I'm gonna rewrite it here. We know that I is I squared is negative 1, I cubed is negative I to the 4th is 1. How about I to the 5th? You can rewrite this as I to the 4th times I. I to the 4th is, we know that it's 1 times I is equal to I. So I to the 5th is equal to I. How about I to the 6th? That's I to the 4th times I squared. we know that I to the fourth is 1, I squared is negative 1, so this is equal to negative 1. So I to the 6 is equal to negative 1. Do you see a pattern here? What's going to be I to the 7th? Or I to the 8th? I to the 7th is, yes, negative I to the 8th is 1. Very good. Look at the pattern here. Look at the first 4. I, negative 1, negative I, 1. The next 4, I, negative 1, negative I, 1. And so on and so forth. It's always going to be like that. Okay? So and so on. And once you get through 4 steps, the cycle repeats. Now, how do we simplify I to the 35th power? Of course, I don't want you to write it down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on and so forth. Okay, so the easiest way to do this is, since it repeats the cycle every after the 4th step, so you just always have whatever that exponent is divided by 4. So 35 divided by 4 is 8. 8 times 4 is 32, and remainder is 3. Right? So, meaning you can rewrite this as I to the 35th (4 times 8 is 32) times I cubed, and this is what we know about I to the 4th. I to the 4th is equal to 1, and I cube is negative I. So the answer is 1 times negative I is negative I. Okay, so again, all you have to do is whatever your exponent is, divide it by 8. Or another one to remember this is, if you have it here, this is the remainder R, this is R, remainder. 0. Since you're dividing it by 4, you will always get a remainder, either 1, 2, 3, or no remainder. Okay, so you just have to use the remainder. If the remainder is 1, the answer is I. If the remainder is 2, it's negative 1. If the remainder is 3, it's negative I. If there's no remainder, that is 1. Okay? Let's try. I'm going to give you another example here. How about let's try I raised to, what do you want? 781. So all we have to do here is we divide 781 by 4. 781 divided by the 4. What is the remainder? It is, when you divide this, is 195 and 1 over 4. So the remainder is 1. So since the remainder is 1, so this is equal to, the remainder is 1, is I. So I raised to 781 is equal to I. Okay, so take note of this again, the power of I. The answer here, I, negative 1, negative I, and positive 1. And if you want to look at the remainder, this remainder here is 1, 2, 3, and no remainder, 0. So this is all you need to remember. Okay. Next. Alright, let's work on some lecture questions here. So for the following exercises, perform the indicated operation and express the result as simplified. So let's do this. 3 plus 2i plus 5 minus 3i, combining like terms and write it in standard form. So 3 plus 5 is 8, 2i minus 3i is negative I. So this is the answer. Number 21, negative 4 plus 4i minus negative 6 plus 9i. You have to distribute the negative here. So negative 4 plus 4i, negative is positive 6, negative times positive 9i is negative 9i. And this is equal to negative 4 plus 6 is 2, 4i minus 9i is negative 5i. Then 28, 4 minus 2i times 4 plus 2i. This is sum and difference of two binomials. So you just have to multiply the first terms. 4 times 4 is 16. Negative 2i times 2i is negative 4i squared. And remember, I squared is equal to negative 1. So 16 minus 4 times negative 1 is equal to, yes, 16 plus 4 is 20. Then 35, 3 plus 4i over 2 minus I. Remember, you have to multiply this by the conjugate of your denominator. So 2 minus I is, multiply this by, that's correct, 2 plus I over 2 plus I. So 3 times 2 is 6. 3 times I, 3i, 4i times 2, 8i, 4i times I is 4i squared. And here, again, sum and difference, we just multiply the first terms. 2 times 2 is 4, and the second terms. Negative I times positive I is negative I squared. So 3i plus 8i is 11i. 4i squared is, I squared again is negative 1. Like this also. So this is equal to 4 times negative 1 is negative 4. 6 minus 4 is 2 plus 11i over 4 minus negative 1 is 5. And if you write this in standard form, so 2/5 is the real part and 11/5 I is the imaginary part. Okay, last one. 51. I to the 7 times I, if we distribute this, is I to the 7th plus I squared times I to the 7th is, we add the exponents. 7 times 2, 7 plus 2 is 9. And what do we know about I to the 7th? 7. If you want to divide it, say here, 7 divided by 4, remainder is, this is 1 and 3/4. Remainder is 3. Right? And the other one, 9. So 9 divided by 4 is equal to 2 and 1/4. the remainder is 1. So if the remainder is 3, what is that equal to? Yes, the answer is negative I plus. How about if the remainder is 1? Yes, the answer is I. And negative 1 plus I is equal to 0. So the answer for 51 is 0. Okay. And that's it for section 3.1. Thank you.